Hi everybody, today we're going to talk about rates of change and behaviors of graphs. The average rate of change is the amount of change divided by how long it took for the change to occur. For applications, we're usually dividing by time. To start us off, we are going to look at this graph where it gives the percent of young adults, which are 18 to 29, that live with one of their parents. So we are going to find the average rate of change from 1940 to 1970. I'm going to look at 1970 where it says 31% of 18 to 29-year-olds live with a parent. And then I'm going to go back to 1940 where it says 48%. And then I'm going to divide by 1970 minus 1940. 31 minus 48 gives me negative 17. Then 1970 minus 1940 gives me 30. I'm going to stick with this graph, but I'm going to change the range of years. So now I'm looking from 1980 to 2020. So in 2020, it said 52% of 18 to 29-year-olds were living with a parent. And then in 1980, it said 32%. So I'm going to do 52 minus 32, 2020 minus 1980, which says this is 20 over 40. I'm going to reduce that to a half. Let's do one more where I kind of put those two together. So I'm going to compare 1940 up to 2020. So back to 2020, it said 52%. In 1940, it said 48%. And we're going to go 2020 minus 1940. So here we see a difference of 4. 2020 to 1940 is 80 years. So this is 1 over 20. Hopefully this is already reminding you of slope and it feels like something we've done before. We can look at this in many different ways. So that was looking at a graph. We could also look at a chart. I made this chart by pulling Tesla stock over a period from January of 2017 up to January of 2021. I'm going to use that chart then to find the average rate of change over some different time periods. So I'm going to start with finding the average rate of change from January of 2018 to January of 2019. In 2019, the stock was 60.45. In 2018, it was 63.62. And we know that's only 1 year difference. So I see that's a negative 3.17. I'm not going to write divide by 1. Let's do that for another set of years. I'm going to go from January 2020 to January 2021. So in January 2021, stock was $826.16. In 2020, it was $296.63. And again, here's this 1 year, 2021 minus 2020. This says this was a change of 532.53. And then our last one, I'm going to do over the whole time period. So from January of 2017 to January of 2021. So in 2021, it was 826.16 again. 2017, it was 45.80. And now I do have a bigger time period, 2021 minus 2017. That said we had a difference of $780.36 over that time period. And then we're dividing it by 4 because that happened over 4 years. That shows us the average increase was $195.09 per year. We can change that and write it algebraically and look at this with functions by finding f of b minus f of a over b minus a. So let's take this function 3x squared minus 5 and let's find the average rate of change from x equals 1 to x equals 3. So I'm going to write f of 3 minus f of 1 over 3 minus 1. So I'm first plugging 3 into the 3x squared minus 5. So I have 3 times 3 squared minus 5. And then plug in 1, 3 times 1 squared minus 5. All over 3 minus 1 is 2. So I think about 3 squared is 9. 9 times 3 is 27. So I have 27 minus 5. 1 squared is 1. 3 times 1 is 3. I have 3 minus 5 still over 2. 27 minus 5 is 22. 3 minus 5 is negative 2 all over 2. So 22 minus negative 2, that's 24. I divide by 2, that's 12. At any time, you could have picked up your calculator to get to this place. Same function, 3x squared minus 5. This time I'm going from 1 to 6. So I do f of 6 minus f of 1 over 6 minus 1. So I have 3 times 6 squared minus 5 minus 3 times 1 squared minus 5. 6 minus 5 is 5. So 6 squared, 36. We're going to do times 3 minus 5. 1 squared is 1 times 3 is 3. This is 3 minus 5 all over 5. So 3 times 36 minus 5 gives me 103. 3 minus 5 gives me negative 2. So I have 103 minus negative 2, which is 105 over 5, which is 21. What I want you to see here is that we got a different answer. I used the same function, but I changed my interval. So when I went from 1 to 3, it changed by about 12 each time I moved my x. But if I went from 1 to 6, on average, I was increasing by 21. So I changed the function. Now I have x cubed plus 4, and I'm going to go from 0 to 3. So I will do f of 3 minus f of 0 over 3 minus 0. This is 3 cubed plus 4 minus, let's do parentheses, 0 cubed plus 4 over 3 minus 0. You can put the 3 cubed plus 4 in parentheses too. So that's 27 plus 4 is 31. 0 plus 4 just gives me 4. That's over 3. So 31 minus 4 is 27 divided by 3. This says I have an average change of 9. So now that we kind of have the feel of how to do that with a function, let's look at that by evaluating a graph. So looking at the graph, I want to find the average rate of change from 1 to 3. So at 1, it's at 2. And at 3, it's at negative 2. If it helps you, you could write down the points that you have 1, 2, and you have 3, negative 2. So I'm doing the change in y, negative 2 minus 2, over the change in x, 3 minus 1. I have a negative 4 over positive 2, which is negative 2. Same thing, look at the graph, but now we're going to go from 2 to 4. So 2 has a y-coordinate of 0. 4 also has a y-coordinate of 0. So when I do the change in y, I have 0 minus 0. Change in x, 4 minus 2, it says it didn't change at all. What that says, if you look at the graph, you can clearly see it went down and then went back up. It's like a net effect of being 0 because they both start at the same place. I'm going to pick a different graph, but I'm still going to do the same average rate of change. So the first one says negative 2 to 1. So negative 2 looks like it's at negative 4. And 1 looks like it's at 8. So I'm going to do 8 minus negative 4 over 1 minus negative 2. The numerator, 8 minus negative 4 is 12. Denominator, 1 minus negative 2 is 3. So my average rate of change is 4. It's positive, and I can see I went from negative 2, 1 up to positive 1, 8, so it did go up. Let's look at negative 3 to 0. So at negative 3, I'm at 0. And at 0, I'm at 6. So I do 6 minus 0 over 0 minus negative 3. I get positive 6 over positive 3, which says my average rate of change is 2. So I'm going back to the functions, but I'm going to change it slightly. Now when I find the average rate of change of x cubed minus 4, I'm looking at the interval 2 to t. So I don't have a number, I have a variable. So we're going to do f of t minus f of 2 over t minus 2. So I plug in the t. That's t cubed minus 4 minus, I plug in 2. 2 cubed minus 4. The denominator is t minus 2. So t cubed minus 4 minus 2 cubed is 8. I have a minus 4. I'm going to leave the denominator. Let's keep our t cubed minus 4. Minus 8 minus 4 is 4 over t minus 2. So I have t cubed minus 8 over t minus 2. Now this particular one, maybe we got lucky, maybe we got unlucky, but we can factor this. T cubed minus 8 is t minus 2 times t squared plus 2t plus 4. And then I have a t minus 2, so I can cancel that. So here's my t squared plus 2t plus 4. Maybe you have to kind of go back and look at how do you factor a difference of cubes. Hopefully you have that somewhere in your notes, but if I get something like that, it's nice to reduce it. So I changed the function. I have x squared plus 3x, and my interval is 4 to 4 plus h. So I'm going to start f of 4 plus h minus f of 4 over 4 plus h minus 4. So I have 4 plus h squared plus 3 times 4 plus h. I'm taking this 4 plus h and I put it wherever the x is. I'm going to put big brackets around that to say that was just my first piece. Minus, plug in 4. I have 4 squared plus 3 times 4. The denominator, the 4's cancel. I just have h. 4 plus h squared, that's a big one. So I have 4 squared is 16. 4 times h is 4h, times 2 is 8h, and then h squared. Remember, when you square a binomial, you get a trinomial. Say you get stuck, what will you do? You will write down 4 plus h times 4 plus h, and you will FOIL, right? You'll just expand it out, you'll get the same thing. 3 times 4 plus h is 12 plus 3h, minus, let's go back to these second brackets, 4 squared is 16, 3 times 4 is 12, all over h. So I'm going to do something weird, but try to stay with me on this. I'm going to leave 16. I have 8h. I have h squared. I have 12. I have 3h. I'm just going to distribute this negative. I know I can add 16 and 12, but I want you to see something. Minus 16 minus 12 all over h. I have negative 16. I have positive 16. I have negative 12. I have positive 12. I wanted you to see that was going to happen, because this idea of doing something plus h is something we like in mathematics. It's a big part of calculus, so I want you to see it early so that you won't be like shocked by it later. Everything you have left has an h. So let's factor an h out. I have 8 plus h plus 3 over h, and the h cancels. My average rate of change is 8 plus h plus 3. I don't know why I didn't do it already, but I can add the 8 and the 3 together, so let's go ahead and call that 11 plus h, and this is my final answer. So the other part that we want to talk about in this section is behavior of graphs, and specifically we want to look at increasing, decreasing, and constant parts of functions. Sometimes functions will only be increasing, sometimes they'll only be decreasing, and sometimes they will switch. Parts of them could be constant, or again, it could be the whole thing. When you're reading the graphs, it's really important that you're going from left to right. So when a function goes up left to right, we call it increasing. When a function goes down from left to right, we call it decreasing. And when it's flat, so think horizontal, then that's called constant. Now, as you're doing these functions, you are going to use interval notation, and you're going to say open intervals, so I want you to know that from the beginning. So again, I went back to an application. This one looks at the Nintendo Wii versus the Nintendo Switch, and it's looking at worldwide sales. So let's just start by looking at the Nintendo Wii, which is the blue bars, and say when was it increasing? So when I look, I can start at year 1 and see it goes up, and it stops. So if I'm thinking this is year 1, this is year 2, this is year 3, I would want to say it's increasing from year 1 to year 3. And then when does it decrease? Well, starting in year 3, 4, 5, 6, 7, 8, 9. I don't even really see it in 10, but it's kind of really there. So we want to say from 3 to 10. Now let's look at Nintendo Switch. We want to know when was it increasing. So I look, it starts in year 1. It's going up, it's going up, it's going up, it's going up. This one that's light says that's like a projection, so we don't know anything about that yet, but we definitely can see from year 1 to year 5, we had an increase in sales. This is me just being extra here and saying, remember, I gave these answers as open intervals of the domain. So I didn't tell you what the sales were. I didn't talk about the millions of sales they had. I only told you the years. So what's happening is I'm giving open intervals of the domain. So make sure when you're giving your answers for increase, decrease, constant, you only talk about the domain, which is the axis. So let's start back. So let's look at some graphs and talk about increasing, decreasing, constant intervals. So what I'm going to do is just say, hey, I'm starting over here and I'm moving left to right, and I notice I'm going down. I stopped going down right here. So from negative infinity until I got to positive 3, I was decreasing. At x equals 3, I increase, and I keep doing that forever. So I say from 3 to infinity, I'm increasing. So I don't give points, I give intervals. That's really important. Let's try it again. This time, I'm starting on the left from negative infinity, and I'm going up until I get to negative 2. So negative infinity to negative 2, I'm increasing. When I get to negative 2, I go down. until I get to x equals 2. So negative 2 to 2, decreasing. Then I get to 2 and it's flat, so we go 2 to infinity. We say that's constant. Right, here's another one, kind of curvy looking graph. So don't let the arrows fool you because the arrow looks like it's going up, but we read left to right. So we really think we're starting going down. So from negative infinity until right here at negative 2, I'm decreasing. Then it goes up. So from negative 2 until here, so that's negative 2 to positive 1, it's increasing. And then from 1, it goes down forever. If you are asked to put this together, like if it says increasing blank, decreasing blank, you would have negative infinity to negative 2 union 1 to infinity for decreasing. Some books use union, sometimes they use a comma, really look at what it tells you to do in the instructions of how to enter the answer, and then you could just leave negative 2 to 1 as you're increasing. So just know sometimes you do have to put two intervals together and it's either a union or a comma, just depending on the book you're using. Along with that idea of increasing, decreasing are these things called extrema. So you might have a local max or a local min. I think your eyes pop at it already, like here. This point is a local minimum. What happens is it's the smallest of everything around it. So when I look at everything around it, this is my smallest point. Notice it happened where it changed from decreasing to increasing. So my local minimum is at the point 3, negative 2. So my minimum is negative 2, and it occurs at the x value of 3. So x equals 3, negative 2 is the min. We can have both a min and a max on the same graph. So here at negative 2, negative 4, I have a local min. And then over at 1, positive 8, I have a local max. I want you to notice these places are where it changed. Decrease, increase, it created a min. Increase, decrease, it created a max. Part of the idea of it being called local is this negative 2, negative 4 is not at all the smallest point on the graph. I have smaller points on the right. This 0.18 is not the highest point on the graph. I have bigger points to the left. What we're talking about with local is comparing to what's around you. So we're not looking at the entire graph. We're just looking at these particular places. So I hope that was a good introduction to looking at average rate of change and what graphs are going to look like. We will continue to talk about functions and different properties they have in the coming videos.